Okay, yeah, thanks for coming, everybody. My name is Francis. I'll be teaching today's workshop. This is the R intro of the programming basics workshop. And we'll have another workshop in a couple of weeks about tidyverse, which is what people usually use when analyzing data in one of them. So can people hear me okay?
Yeah.
Okay, great. If I'm too quiet, let me know. I'll take you back more. We have two TAs for today. Josh is here for the first 10 minutes. Yeah, he's really Richard. And Richard, the real Richard, will be here in about 10 minutes to take over from Josh a little. And we're going to start with a quick Git review and making sure people get set up correctly. We'll go to an intro to RStudio and R, and then we'll go to the programming basics. So is there anyone here who left early last week who was not able to set up GitHub in their DCC? Okay, I heard there were some people, so just in case, I'm going to take you through this again. To start off, you'll want two tabs open really. One's this Git repository that I think we don't link to. You can also just find it on GitLab if you log in. And we also have this DCC container open. So go ahead and log into those two pages, and then I'll give you a minute or so. And you can also just raise your hand and give questions. Yeah. What is the Git? Yeah, good question. Is there a link to that?
So if you go to the main page for the GitHub, there is there's a bit.ly, scroll down. Yeah, right there, there's a bit.ly. So if you open that, then that's probably the area.
Okay,
But
so
it just takes you back there, but then, and then to clone it.
yeah, I do know what you're doing.
You want me to do it or?
Oh, no, it's okay. I think I know how to do it. It's,
And so, but the clone link is up at that.
yeah, phone it up. So go ahead and type in this bit.ly address. And try to find it. Oh, you guys, you open up so you can. Oh, good. Okay, so you'll want to copy that bit.ly address there. Oh, sorry. I can try writing it down if it's probably something easier. Flash bit. Three. One. Okay, so you should be at this GitLab at this point, and you should have your DCC open. So we're first going to open RStudio on the DCC. So to get there, you go to Interactive Apps. You can click on RStudio. And it should take you to this page over here where you can give yourself some parameters about what you want your DCC session to look like. So I think you all should have access to this HIV R25 2022. Okay, great. You can choose the CHSI partition.
Actually, they should do CHSI high. I think it's on.
This one? Okay. So go to the CHSI high partition. And you can set your wall time for about 4 hours or 3 hours. And you can leave the defaults the same. Okay. Then we need to just slow down.
Defaults, the defaults are probably going to be different from what you think.
Probably.
Yeah. That's okay.
Yeah, and that's okay. All right, everything else should be good to go. So just go ahead and press launch. And then once it shows up, you can access your RStudio and the DCC by clicking on the button down here. Okay, so this is not the right project. So for those of you who cloned this last time, you should be able to access your project from RStudio, and that should be the 2022-2023 content. Okay, so if there are people who have not done this, the way we do it is we go to this GitLab page. We can go to a clone button over here at the main page. Yeah. And clone with HTTPS. Yes. Yeah, I think most people should have this already, which is good. This is just a review in case people don't have it. So once you clone, you go back to RStudio, you make a new project. Version control. We go to Git. Oh, we have a question, yeah.
So can we go back to the cloning part?
Yeah, for sure. So we're on the main page of our GitLab that we want you to copy basically into our repository and edit. So if you're on the main page, you see this blue clone button. Do you see that?
Yeah.
Okay. And then you're going to press this copy URL button next to HTTPS link. So this link is what lets us connect this remote GitLab with our own RStudio session. So once you're there, once you have that copy, you're going to go back to your DCC or RStudio. You're going to make a new project under File. We're going to go to version control. And we're using a Git, so we're going to click the Git button. And we're going to paste our remote repository URL. And you can save it wherever you want in your local directory. And you're going to press create project. And that should copy all of the things from the remote repository into your DCC. Okay, are there any questions? People successfully cloned in?
I'm getting a window that says that it already exists.
Oh, that's so you already did it, so that's
Okay.
good. Yeah. All right, so everyone should have this open now. I'm gonna close all these because you don't think they're working on. And I think one thing I'd like to do before we all get started is I'd like all of you to navigate to the folder that we'll be using today. So you should be in this folder, in this lower right corner of the screen. We're going to be working in the data science folder today. So go ahead and click on data science. And then intro to R. You don't have it?
I have it.
Some people have it. Okay. Oh wait, that's why we had to pull. Okay. So these are new changes that I've made in the past week. And last week these weren't there. So this is what's cool about Git. So if you push the Git tab and you click at this green arrow, blue arrow, and you click it, then it should update your repository from the remote. Okay. Yes.
So mine says it's up to date, but I don't have all of them. I only have maybe like 6 files in that folder.
That's okay.
That's okay.
We, Francis has some files, but she hasn't put in the detail. So that's so, as long as you have that directory, you don't have the.
Oh, yeah, that's right. Mhm, yeah, that's right.
I can see your.
Yeah, there's a lot. Okay, do people have all the files necessary? Or there should be 4 of them really, I think.
And then, I'm guessing they're all gonna be not hard.
Yeah, but that's the hard file.
This one, there's one that's CSV and one that's.
Okay, that's fine too. All right, great. Okay, if there are problems, feel free to go ask Josh. Okay, so, I guess it was time to give a brief introduction to R and RStudio. So, has anyone used R before here? Yeah. Okay, some people, that's cool. So R is a language that a lot of statisticians use when it comes to analyzing data. And we prefer it over Excel because Excel is not reproducible. Basically for R, you can go back and trace every output that you have to a specific code chunk. And you can't really do that in other things like Excel. RStudio is a way of working with R. So this thing that you see here is RStudio. It's going to be called Posit soon. They're renaming it for some reason. But it's a pretty nice environment for working with R, helping it connect to Git, and making some nice files. So some of these nice files include RMDs, and you won't see all of these things here, but you can click on the first 00 underscore RStudio RMD. Okay. I guess what do you have when you pull? Okay, and then keep. Can you reload? There's this little. There you go. Yes. Try. No. Okay. Interesting. Are other people missing this folder, the data science folder? Or not the data science folder, the intro to R folder? Yes. Okay. How many people are missing this intro to R folder? Only a few people. Yeah, that's interesting. There might be 2 versions of this. I remember seeing 2 versions of this in 2003. So that might be why. Okay, so we have 3 people. Oh, wait, you're gonna have to. Yeah. Okay. They just have the pool. Yes, the pool. Okay, great. So we have 1 person.
We have probably here. She got to do so,
Yeah. It's 2 people.
well, there's several reasons in there and they're all public. We got the intern.
Yeah. Interesting. I
Okay,
think it's probably.
you're good. Okay, well.
There's probably 30%, that's probably. Okay. Oh, okay, what's happening?
We don't have the good tab.
You don't have
We
a
don't have the good tab,
okay. Yeah. I would suggest. This morning.
Okay, hold on. Let me look at the-
Yeah. Yeah. See this line? Yeah. Okay, no problem. All right. I guess for those of you who do have access to it, you can just open up this RStudio RMD. And what I'd like you to do is I'd like you to make a copy of this. So make a, I guess, check mark it in the file system. Then you're going to make a copy with this drop down next to the blue settings. And you're going to rename it, name this copy to end with a underscore MINE.
Yeah.
Overall, yeah, yeah. Okay, no problem. All right, so again, the thing about this Git repo is that you do not have push access to it. So you can make edits on the local copy here, but you cannot push it to the remote because you are not contributors. So in order to make edits and have you be able to save them and take notes, you're going to make copies of these and make sure they don't end up on the remote Git. So you're going to check mark this 00 underscore RStudio.rmd, and you're going to make your own copy. So let's check mark it. Go to this drop down next to this blue settings and copy. And this is special. In order to make this work, we'll need to rename this to end with a underscore MINE, capital. And then press OK, then you should have a copy that you can work with. Okay. This part is kind of optional, so people who are left behind or not ready yet, you can just listen. But those of you who do have this open, go ahead and open it. And this is just a short intro to RStudio and R Markdown. So this sort of file that you see is called an R Markdown. It ends with a .rmd. It's a special type of document that Josh actually talked about last week. And it allows us to integrate both plain text and code in the same document, which is pretty cool. So right now, it looks like a whole bunch of text. You have some code chunks. And what happens is that you can knit this into a nice format. So if you press on this knit button, this blue yarn, it knits by default to an HTML.
So is knitting just like converting the file format?
Yeah, knitting is just converting the file format to something readable. So the nice thing about this is that we can make this pretty customizable, and we can use this RMD format to both comment and analyze code. And yeah, this is Richard, one of our TAs for today. So if questions, feel free to ask them as well. All right, so we're talking about R Markdowns right now. And one nice thing about R Markdowns is that you can integrate code into the plain text. For example, this sentence I'm highlighting right now has some inline text denoted by this these ticks and this R. And sys.date just gives us today's date. So if you knit this today, then you'll see today's date, 10/6, yeah, 2022. But if you knit this tomorrow, you'll see a different date.
Yeah, is there anyone else who isn't like us with having, okay.
Yeah, thank you. So, this is really nice when you're writing reports, for instance, because if you have data which changes, like if you catch a mistake in your data, usually if you wrote a report in Word, you have to go back and change it manually for each mistake you see. But for this RMD, you just change the code and it'll just automatically change within this RMD. Yeah. So you don't have to do it. It takes a lot of time when it comes to making reports. So we talked about these inline code chunks. You'll see more of this later, probably. I'd like to go back to basics and talk a little bit more about how do we edit these RMDs. So we can start with some plain text examples. So if you want the text to show up, all you have to do is just type in this white space. So if you want to add something new, like a new paragraph, maybe some notes over here. You can just type. And once you knit, it'll just show up in the resulting HTML. You can see some notes here. Okay, so plain text is pretty easy and straightforward. It's pretty much the same thing as in Word. Now, how do we do headers? We can do headers with these hash marks over here. The fewer hash marks you have, the bigger the font. So one hash mark, is pretty big. Two hash marks is smaller, like a subsection. And you can do 3 hash marks. And I don't think you can really do 4, but 1, 2, and 3 usually is enough. So let's hit again. It's a little bit bigger, yeah. A little bit maybe. Okay. Are there any questions so far on stuff? Yeah. If not, we can talk also about special things like bolding font, which you can do using this asterisk around the plain text. And one nice thing that Richard actually introduced to me a while back is this visual editing mode. So if you click on this visual tab, you can get a preview of what's going on. And you can also manually edit this by bolding or italicizing. And if you look back at the source, it contains over as well.
How do you get the source and visual tab? Like,
Yeah.
For some people, if you're in an older version of RStudio, above the scroll button, there's something that looks like the head of a pen. People see that. You click on that, it should switch.
Oh, no, it's okay. I didn't know that.
Yeah, no worries.
So people don't have the source and visual? Interesting. Okay, I think like you said in your RStudio version, they should have it.
And yeah, so they just moved where it was. So the new RStudio, they put source and visual. Old RStudio, they just have a little pen above the scroll bar.
Above the scroll bar?
Yeah,
So somewhere over here.
somewhere over there. Yeah.
Okay. Let's see.
It still doesn't look exactly like that. But if you click like the little gear, like the settings button, then you can click the visual mode.
Okay, that's nice.
If you want to just do it.
Yeah, for sure.
The heading and stuff is right here, but you just click down here for the visual.
Okay. Yeah, thank you. That's cool. All right. So let's see if I can find it here. Another way of accessing is going to this settings button next to the knit button and clicking on the visual editor mode. Yeah, thank you. Okay, so you can take maybe a minute or so, you can just edit some things, add some headers, add some italics or bolds, add some notes, and try to see how that changes your knitted RFG. So you can do that, like you can scroll down. And add some text. Yeah, you can add text there, yeah. If you have any notes, or if you want to change the formatting or add a header.
Look after.
Yeah.
Or if you go into the visual.
Oh, yeah, okay.
You space it.
I was just,
No, no, they should do it.
oh, yeah, try doing this in.
So that's the folder.
I mean, I was.
I like it. Too bad.
Yeah. Oh. Wow, okay.
Separate.
Yeah.
Get them marked down.
Oh, I can.
Oh, yeah.
I don't know. So you're still.
Familiarizing ourselves. But if you want to go back into that, and it's more your. I think.
Oh, yeah. So that's the convert. The workers.
And then if you scroll down. And see it's kind of a preview. What is it? Yeah, and you can. Yeah. No, it should. Okay. All right, so I think we've done enough about plain text for now. We're not going to talk about code chunks and how to add code to your RMD. So this will come in handy later if you want to add in tables or graphs into your report. For now, we'll start something pretty simple. We'll just add a code chunk which prints out a message and maybe adds 2 numbers. So this is already there, but you can create a new code chunk by pressing enter a few times. That you shoot a place where you want to have your code chunk. You're going to press R, and then you're going to press Shift Tab if you are a Windows user. Yeah, so R Shift Tab if you are a Windows user. And I should have put this up for Mac before. But another way to add it would be to go to this insert new code chunk.
It's the same color.
It's the same for Mac. Okay, great. Awesome, thank you. You can also just add a new chunk using this drop down and then add an R chunk. So what shows up is an empty code chunk. It's always noted by these free ticks, and then you're going to have an ending free ticks and this braces and R in the middle. And this R just denotes that's an R chunk. So this label is optional, but it's usually good practice to label your chunks of code. So, for example, below I've named my code chunk printing hi. So if you have a new label, let's just make this be 8 divided by 4 for now. You can name it something like division, right? Or whatever you'd like. And this options is for code chunk options, like if you want bigger size to be different, or other things. You don't need that for now, so I'm just going to delete it. And now if you knit, you'll see another code chunk in this gray box and the output in this white box underneath. Okay, are there any questions so far? All right, great. Okay. Also, as a side note, you can hide these code chunks. If you just want the output to show up and not the code chunks, then you can change this setting up here to echo equals false. So echo just refers to whether you echo the code chunks in your output or not. So if you set echo equals false, and then you knit, then you'll see that the code chunks disappear and you just have the output. And this is analogous to what will happen if you are trying to plot something and you don't want to show the plotting code and you just want to show the plots. Okay. Yeah. That's it. Pretty much for this. This is the YAML, YAML, and it just gives us some basic information that's printed out every time we make an RMD. You can change these as well. You can change the title, subtitle, author, date. And you can also change whether they have a table of contents or not. So this is pretty customizable. Okay, I think that sums up our talk about RStudio, R, and RMDs in general. Very basic overview. Are there any questions about anything we've seen so far? Okay, hopefully people can see why this is useful. Yeah. Oh.
So it's with that, so it's right.
Yeah, I think it chose a little bit. Yeah. So you're
like.
Yeah.
Yeah. You here.
Yeah.
When I I'm not getting
Yeah, that's probably. No problem.
But yeah, I don't know why it's not.
You could still like.
I'll give you a few more minutes to just play around with this, and then we'll move on to our next section.
Okay. And then you may like also be there and you can still have it.
Something in there. There's like 6. There's like 10 divided by 4.
Yeah, actually, that's a good exercise. So I will, yeah.
Well, that's one word around it.
Okay.
Now, yeah, I don't know, there maybe a pop-up setting or something.
Okay, so I got a question on what this first code chunk is. So this is the setup chunk, and it shows up in all the RMDs that you make, no matter what you join. And this just sets global options for all the following code chunks. So in this case, this ops _ chunk stands for chunk options, really. And you're going to change the settings here to be echo equals true or echo equals false, so on. So there are a lot of things that you can change about code chunks. You can make this false. You can change the figure height to be universal. You can change figure width. You can change whether you include warning messages or error messages, and so on. So there's a lot of things that you can do here, and you can probably look this up if you're interested in seeing all the possible options that you can have when it comes to choosing what your chunks look like. trying to type those and I got this on my factors.
Yeah.
You need some commas, looks like. So you got commas in between. Yeah. I mean, there's something like this. Okay. It looks like most people are done, so we move on to programming. And maybe we can take a break in, yeah, maybe 20 minutes or so. All right, so the programming is a pretty long R&D. It's this 01 introduction to R. So like last time, if you want to make notes, I suggest that you copy this. So copy this and then do an underscore MIN. Okay, so everyone should have their own copy of this programming R&D. Let me see if I can make this a little bit bigger. Yeah, okay, that's fine. And this is originally developed by Janice, who you'll probably see in a couple workshops. She'll be teaching more of the later data science workshops. And this is just basically an overview of programming in R. So I guess to start out, there are a lot of things that you can do in R. A lot of them have to be imported though from different sources called packages. So what we start with is something called Base R, and that's R of no packages at all. These are all this built-in base functionality. And that's what we'll be going over this lecture. And next lecture in a couple of weeks, we'll go over another package called ID groups. So yeah, Base R is always installed. And we can start by jumping right into what this Base R does, or what it allows us to do. I guess, can I have a show of hands of how many people have any programming experience? It doesn't have to be in R, but in any other language. Okay, yeah. Okay, so lots will be relevant for people who haven't programmed before. But it should be pretty similar to people who have. So we're going to talk about, let me just knit this actually, so you can see what this looks like. We'll be talking about some style things, stuff about variables, data types, operators, looping, and functions. So I think for style, it's good to have a readable code style. As an example, here I'm creating a code chunk. And we can talk about, I think later, more in detail about what this looks like. Things like good variable names, what your code should, how it should be organized, and adding comments and stuff. So I think one guideline is basically add comments to your code. So one way to do this is by using a hashtag, but this time inside of a code chunk. So this basically designates the line that it's on as a comment. For example, if I'm using an example from earlier, 8 divided by 4, you can have a comment saying the below should be 2. And this becomes very important when you have very long lines of code inside your code chunk, or if you have lots of functions or something. I just want you to add a bullet point here, which summarizes what we do for styling. So I'll add comment code here and update that as I go. Okay, so now we know about commenting code and how to do that. In R at least. And we can talk about variables. So variables are things that come in handy when you want to save certain values or data that are pretty long and lengthy to refer to otherwise. For example, this 8 divided by 4. Let's say it was something more complicated, like 8 divided by 4 plus 2. And you're going to multiply that all by 9. So imagine how we wanted to plug this value into something else, like another function or another calculation. It'd be very tedious to copy and paste this if we need to use this many times. So what if we store it instead in a variable, or basically shorthand for what this whole thing is? So we can use this arrow key, which is basically the less than sign and then a dash, to assign the name X to this value. Are there any questions so far on why this is important? Okay. One thing I forgot to tell you is how to run your chunks actually. So if you want to evaluate things within an R&D, you can do one of two things. You can either run this current chunk. If you go to the arrow to the right, it should give you the output. Or you can do a shortcut. For me, this is Control Enter that runs one line in this code. Hopefully it's the same for Mac too.
It's Command Enter.
Command Enter. Okay, thank you. So Control Enter or Command Enter. And one cool thing is that all your variables will show up in the Environment tab. So if you switch from your Git tab to your Environment tab, you'll see that you now have an X with something assigned to it, which is 36. So this arrow here is a default way of assigning things for funsies. I'll show you that you can do it the other way. You can have your value first and then your variable name like this. You can have an equal sign even. So these are all equivalent. Here, you can add a comment naturally and say the below are equivalent ways of assigning variables. So all these are ways of assigning the value 36 to X. But this first one is what we usually use. Okay, so we now know about how to assign variables. If you want to look back at what you typed in or what you've run, you can always go back to history and see what you've done. I don't ever use this tab, so I would not deem it too important. But I guess the next thing that we can do once you know how to assign variables is talk about data types. Here's just another example, I think, of variables that Janus uses. So if you have two variables, 3 and 5, you can use these variables, I guess, iteratively to assign a new variable, in this case, C. So these variables are basically like, it's very useful shorthand when it comes to defining values and using them. Okay, so we can talk about data types now. We have 15 minutes, okay. So we have a few data types that we can talk about that we use in R. So we have numbers or numeric. We have integers, which are numbers without decimals. We have logicals, which are true and false. We have characters, which are words and letters, which are usually denoted in quotes. And we have factors, which are variables that can take only a few levels at a time, like discrete variables. So those are the basic building block variables. But on top of that, we can aggregate these variables into more data types. We can have vectors, lists, and data frames. And these are ways of aggregating multiple types of these data. So vectors are basically lists of one type of variable. A list is a list of multiple types of variables. And a data frame is what you think of when you think of a typical, I guess, analysis data frame. And we can talk about some examples. In fact, maybe we can just make code chunks and experiment with them. Is this showing up? Okay, don't make code chunks in the middle of lists, actually. That's not a good idea. Let's try doing it at the very bottom.
Okay, I think I moved this one. Okay.
Okay, so we can talk about data type examples. And I think Janice actually has examples over here, so I should be using these. But these look like mostly list, data frame, and vectors examples. So we can just talk about the numeric examples for starters. So here, a numeric thing is anything that's numbers. So it can be 5 divided by 3, or it can be 1.999, something like that. Yeah, for logical, it's literally the words true or false. So I think one interesting thing about logicals is that you can give it conditions. For example, let's see. Can I do this? So 1 + 2 is always 3. We know that. Yeah, okay, we can. So logical is true or false, but you also have certain statements which are true or false. So in this case, 1 + 2 is always 3. And we can denote this. We can denote that we want R to check this by using the probability sign. So 1 + 2 + 3 equals 3 is always true, as you can see in this global environment. Let me just rename this. So, but if you say 1 + 2, and you ask R, is this equal to 7? It's false. So, that's always false. So yeah, these are silly examples right now, but they will come in handy, or this sort of thing will come in handy when it comes to working with data frames in the future, in a couple weeks. I think Janice has a question about integers later, so I'm going to skip that. Characters are usually referred to strings. Refer to strings as to, like, yeah, they're called strings in R. So they be things like this. And they can also include numbers or other characters as well. So, for example, this is a string, even though it's the integer up here, because these double quotes mean that we want to treat it like a string or like a character string. So that's good to keep in mind. Finally, we have factors, and I think I'll go over factors later. Okay, so those are some examples of very basic foundational character types or data types. And now we can talk about how to put them together. So here's an example of a vector that Janus has. So vectors are denoted with this C, which stands for concatenate. And we use these parentheses to denote what's inside the vector. So here you can see that this B, if you run it, is a vector of 3 numbers. This W is a vector of 3 strings. Okay, but notice that for these vectors, we cannot mix and match different types. So if we try something like a string, but also a number, it should see it forces, it forces one of them to be a string, even though one of them is input as a number. So we don't want that. Now, the way to get around this is we use a list instead. Or to be forced into a string. So instead of that, we can do a list instead. So if we do make, I should not name this W, I'll name it bad. Okay, so if bad is instead a list, then you can see that bad has a character 2 and a numeric 4, which is what we wanted. So the takeaway is that lists allow different data types. And this comes in handy when you want to store a lot of things and reference them inside of a variable. Like say you have 2 data frames and you have like a name that you want to associate with each of them, then you can store those names and the data frames into one object and make that object a list. And that way you can reference all of them at the same time, which is nice. So lists are pretty important. Okay, so for a lot of this workshop, I guess in these sections, we'll be working data frames. So this is your first introduction to a data frame. You should have this person living with HIV/AIDS.csv in your folder. And if you Control or Command Enter, you should be able to read that CSV in with this read.csv command. And what you can do is you can go to your environment and take a look at what this looks like. So you should see lwib in your environment, click on it, and you should be able to see the entire data frame as a separate tab on your RStudio. Weird. So you should first make sure you run this line over here. lwib is read.csv. So lwib is a variable which saves the CSV format into a data frame. And you can click on lwib in environment and yeah, it shows up. Okay, all these are great questions. Feel free to ask. So it's telling you, yeah.
But then you all this true.
Yeah, so now, yeah, like your condition, you don't know what it's. Yeah. Okay, yeah, question. Susie? Let's see, I think you don't just yet. Oh, we had it.
There is a play.
This is right now. Okay.
Yeah, that's true.
I know, I was in one.
You might find, okay.
Right. I know, I try, right? That's
Oh, you know, otherwise. Oh, it is. So this. Yeah, so it looks like you might have to. Yeah, so right now. But you're on. Okay, are people able to just file in because we shouldn't be able to
Just chunk.
no, you are fine. All right, that's good.
Yeah.
Okay. Awesome. Okay, so why I'm skeptical that you would be able to do this is because right now this read CSV, what it does is that it looks at this file path and it tries to read in as a CSV whatever's at that file path. And I think for a lot of you, right now your working directory, yeah, does not correspond to the file path. So I'm just confused. No. But if it works, it's good. Usually what you'd have to do is that since your working directory is in this workshop folder, which is all the way over here, you'd have to add the folders in between, like data science, intro to R. So in those to look in this folder specifically. Okay. That's fine. Okay, we might come back down later. But anyways, you should have this L with it. And that's an example of what a data frame in there is going to look like. Okay. So this head command lets you look at the first few rows of L with. So if you run that, you can see the first 6 rows underneath your code chunk. And as a very preliminary look at Tidyverse, you can load in libraries or tell R to use them using this library command. So if you run that, you now have Tidyverse at your disposal, and you can use new commands that you wouldn't have been able to use otherwise. So this read_CSV command is actually faster than the read.csv that comes in base R, which is why we can use it. And it only exists because you're able to load in Tidyverse. It's a Tidyverse specific command. Yeah.
I didn't know whether you explained what Tidyverse was.
Yeah. So Tidyverse is something that we'll be going over in 2 weeks. So it's a package that we'll be using for most of this, most of these workshops right now. And it's used for visualization and also visualization and data wrangling primarily. Okay. We don't need that for this session, so we can also detach the package and unload it. And I think it's time for a break, so we'll be back in, maybe 5-7 minutes. Yeah, 5 to 7 minutes. Okay. Any questions that you ask Richard or Kate? Yeah, I said I would go more than I could. Yeah, I think.
Yeah, I accepted it.
Yeah.
She.
I.
Yeah.
Wait out.
Yeah, you.
That's right.
Well,
I mean, we have the guys.
Because one of my.
Yeah. Yeah.
I kind of wanted.
I wanted to.
That was 25. I should be like, we don't have a lot of.
I didn't know. Right, there's a lot of anxiety because you're not, there's a lot of uncertainty. Right now. But it all works out. It's like right.
And he was like. Yeah. My bike's and No, it would be about. There's a lot of different. Yeah. So there was like,
So, exercise for that going. So if you go to your, O1 and go to where we stopped, there should be a few exercises right after that. And it's a good opportunity to practice taking coach up and making, I guess, different data types and variables. So feel free to work with them with other people around you or by yourself. And if you have questions, then you can let us know. Also, as a add-on, the first question says you can look up the function seek. So there are two ways you can do it. You can either look on Google and just type in RSeek and look at a documentation. And the documentation has description, it has, I guess, descriptions on what goes inside the parentheses or arguments. And it has examples at the bottom, which is nice. A shorthand for doing that in the RStudio is by doing a question mark and then seek. And it shows up in the bottom right. So either one of those is good. You could copy it. You could copy it and then just change those inside. Yeah. Good. Yeah, you could do that. So. Yeah, so we're going to make an archway. You can, in your mouse, I guess it'd be R. Actually, you know what, it's in this version is from here, that's one, and the first option, yeah, there you go. And now you can start down to each one. Okay. Yeah. One of something that I loading this, and now instead of consoles, just like. Let's see, you finish up your sessions. Did you do this for 4 hours or? Yeah. I thought so. Okay, it looks like it's not, yeah. So yeah, you can create a new session and it should be able to, yeah. Okay. Yeah. And you know, one sense we have to, this is the one. Yeah. That's the example, so it's. So it does help a lot. Also, the arguments.
Yeah, I think that's, it feels like one of them.
Yeah, but if you want something to add to nice
I guess that is not right. This is right now.
And then I would type it
Instead of being by 2.
So I think the change where it starts from.
Okay, so you always have to do that.
Yeah, so it's gonna do 5 2 from the first, so that's why it's there on the 3 o'clock. Okay. Yeah.
Okay, so I want you to
Oh,
at least start giving hints for the first one and then I'll link to the second one. So here the seek function is very important. It's what you're supposed to be using. So if you look at a documentation, if you want to pay attention to 2 sections, one is the argument section and one is the example section. So you can see that seek from examples, it takes usually free arguments, which are what we just call things that go inside of the parentheses. So this function called seek takes in these numbers and spits out something else. And what these numbers are, you can figure out by either copying and pasting these examples into the console and see what comes out. In this case, it's your output. And in conjunction with that, you can also look at the arguments here to figure out what these things inside of the function mean. So here we see that the sequence seek has the arguments from, to, by, link.out, and long.with. And by default, this is the first, second, third, fourth, and fifth arguments in the function. So here in this first example, we see three arguments. The first one's from, the second one is to, and this third one is special because it's not by, it's link.out. And what this means is that we output a sequence that goes from 0 to 1, and there are 11 entries in it. So usually if we have, the way we're doing this is by saying by equals 0.1. And that gives you the same answer because it's listing all the numbers in between 0 and 1 by 0.1. So using the same argument or the same thinking for this, we want the first even 10 even numbers. That's right. So one way of doing this is going from, let's see, 2 to maybe. So we can check to see what are the difference. 1, 2, 3, 4. Okay, so it's 2 to 20. But there should be another way of doing it actually. So that's just an example. Keep on going. And if you have questions, let me know.
Why not? Yeah. Like,
Yes.
Okay. We'll use this. I feel like there's I don't know I'm not familiar with this.
I would do 1:10.
Yep.
The first,
Oh,
the
I
first
asked
10,
what it
not the
meant.
second. The first 10 good numbers. Like, yes, I think the first 10. It's just,
Next break.
Yeah.
Sticks out.
My computer and so they can't like if you do it.
Sometimes it tells me it's what.
No, so if you want to do that, you want to line.
Yeah, you have to do a test here, here, and then.
Then I do.
Okay, so let's do like the back one. And then video.
Try regular. And also, it's like we can run. First.
Okay, yeah.
Try to follow that. Running at their cooking work. Like run as in, yeah. Working, that's the.
Oh, right, you want to favorite one. One line.
The whole line is coming. Yeah. There you go. So now you can type in.
For like all this information is stored,
Oh,
so I
okay.
so there's just. Then two county.
Yeah.
He was even the first thing, and now that I've run it, I'm over here. In this environment, you said you want. And then also like reloaded that. That is now loaded in the environment. So you delete it. So it's just showing you like the break that you've defined. I'll show you animation from here. Like if we define a variable in here, but.
Yeah. Okay, so for the first 10 numbers, you could have used sequence, but a much easier way of doing it, a shorthand, is actually just 1:10. So that's one nice way of doing it. So we can talk about making lists. So one way of doing a list is, I guess in this case, just putting list and then the two vectors inside. So if you look at the structure of this list, you'll see that there's two entries. One is a vector of the evens, one is a vector of 1 through 10. And I think one thing to note is that this is very different from if we had tried to do a vector of these. So if we had done this instead, even nums first 10 nums, then it just basically concatenates all these numbers together. So this vector of nums is just a vector of length 20 down. And it's very different from, again, the list, which is above it, and which consists of two entries, yeah, 3 vectors. Okay, so we have our vectors, we have our lists. And now we want to display the first 15 rows of the all width data frame. And the thing that comes to handy here is going to be head. And if you look up head in the documentation, which we can do here, you'll see that we can specify in the arguments an n, which is of integer of length, whatever you want to be displayed in terms of number of rows. So let's try that. Yeah, and there we have it. Also notice that if you run this in R, you can access different columns and rows by looking at, I guess, the interactive table. Okay, I think that's it for exercises. Are there any questions on what just happened?
Move up to the 6 and.
Yeah, move up to the list
Yeah.
section. Okay, are you good? Okay, awesome. Okay, so now we know what sort of types of data we can see in our art. And now we can start to manipulate these things. So we have some operators that are very basic arithmetic functions. And you've already seen a lot of these. Things like minus, plus, multiplication, division. So I think the only thing you might not actually no, you see all of these, so it should be good. You have some more fancy things that have to do with vectors and matrices. So I might kind of skip over these, but we can do dot products. We can do modulus, which is what's the remainder if you divide something by another number. So n mod 5 is 0 because the remainder is 0. Whereas 10 mod 3 would be 1 because 10 divided by 3 is 9, and then you have one more to get to 10. So that's a double percent sign. And yeah, integer division is division with the remainder. So 10 by 3. Yeah, the floor is free. Okay, so those are the basic arithmetic operators. We can talk about logical operators now. And these are things that you'd probably actually end up using in your data frame in the future. So they look pretty similar to what we already use in real life. You have the less than sign, greater than sign, greater equal to sign. So over here, less than equal to sign, equals is does its thing equal letter thing. Not well, the exclamation part is not, so not equals. That's whether something is not equal to something else. And we have to and or operate it as well. Okay, I think I'll add some, we can go through some examples first for going into the exercises. So let's see. Recall that we have our vector b, which is 1, 2, 3. So let's say we want to see whether each value in b is less than or equal to 1.5. If we run that, we get a vector of trues and falses. So let's say we have a more complex vector Okay, we can talk about the first 10 even numbers. So. Let's see, you want to get the even numbers which are less than 7. Or, I wonder if this works actually, more than 11. Sure. Okay. So yeah, these are the true and false designations of numbers which meet the criteria over here. So we can combine these operators to filter out for a lot of things. And we'll be using these a lot later in the course we look at timers. Okay, let me see if you're ready for the exercises that come next. I think you should be fine. Yeah, okay, so let's do the exercises, which come next, and we can move on after that. So go ahead, and if you have questions, go ahead and ask us. Yeah. This. I think I
Oh, yeah, just Brandon, yeah, so just run. So also you just put the cursor. And. Yeah, over, yeah, so now.
So when I do, but it's not popping up.
Or doesn't like it, so.
Okay, I have it.
Right.
But it's still like not like actual. Like,
I don't know.
The slash.
oh, there was like, well, it was like, oh, and when, yeah, I'll show you that we should.
There's a space.
Oh, okay. So what happens, what if that's the state?
You go forward, go to the first.
Yeah, there you go.
Great call.
Yeah. Oh, it looks like the. See how this, I guess this on code chunk is nothing face on grayed out. Try making these, need a space before the place. Yeah, spaces, and then enter after that. And you do it, I see this, I don't know. Yeah, and then make sure.
Oh, you just want to get rid of it.
Yeah.
And so I was wondering how you just figured right.
Yes.
Hold on.
So we're gonna use Oh, okay, yeah, so even.
So,
Yeah, so you didn't put on. Yeah, I think.
yeah, there you go. So that should work. And if I did anything else, it's not right.
We just.
Oh, okay, okay. So yeah, the next time you run it, that you show up.
Oh,
Yeah, so that's more of like a.
Yeah, that's just. No problem.
Yeah, so if you just run that by itself, it'll give you an error, because it doesn't recognize it, like you didn't run the code above. But once you do that, again, it'll be that error. It shouldn't be that error. It may give you a different error. It'll give you that.
Okay, thank you.
Oh, yes, somehow.
Okay.
The joy.
Right?
Um, Yeah, so I think this is just.
Where? Actually,
Online people.
Oh, well, it's also like.
Yeah, those people just have a little more.
Yeah.
No, so it can be a new line, so you press.
Oh.
Yeah, yeah, and then so leave that little ball. And then, and then it just probably even not or even. Yeah. And so that should run it probably. But yeah. So that ran now. Yeah, so then she. Yeah, so it seems like, yeah, there's no error now.
Okay.
Yeah.
Okay. So let's stop for now, and I'll just show you how to answer the first question and then skip the rest. So here, we're just assigning all the variables that it asks us to. I'm just gonna change this back to 3. And once you write out this equation, which is what's over here, and run it, it gives you the viral load at time 3. So what's nice here is that you can get this at many times. So if you want viral load at times 1, 2, 3, 4, 5, 6, 7, 8, 10, then you can just say t equals, well, equals 1 to 10, and it should give you 10 numbers. Okay, are there any questions? Yeah.
Why do some of them have the equal and some of them have the arrow?
Oh, it's the same thing.
Oh,
It's other added.
okay.
So yeah, technically, it's better to have these arrows. It's just more like a benefit.
Yeah, it's not reading it under.
Yeah, it's like a lot.
Oh, okay. No, but this.
Okay, so I guess we can move on to looping. So basically, sometimes they're actually want to do multiple times. So this is where we do loops. So there are different types of loops that you can do. But I'll go over only a couple, I think, today. So, we can start with something called a for loop. So, a for loop basically takes in a vector of numbers or a vector of something, and it does something to each of those things in the vector or list. For example, we have this vector v, which looks like this. Let me just print it out. And say that for each entry in this v vector, we want to multiply it by 2. One way of doing it is by using a for loop. So what this is going to do is it's going to multiply the I entry in B by 2 for I in 1 to length B. This might be a little bit of a mouthful to take in at first, so let's just break this down. First of all, what is length B? It is 7. So this is the same thing as saying for I from 1 to 7, do this. And I here is going to be 1 to 7. So it's saying that the first entry of B is going to be 2 times the first entry of B. The second entry of B is going to be 2 times the second entry of B, and so on. So right now we have this B, and once we run this for loop, it's going to multiply everything by 2. So you can see here that this is 2 times the entries in B. Are there any questions about that? Another very basic example, I just want to see what I does. Actually, you know what? Let's not do this. Let's just add print I inside this for loop. So you see each time this for loop runs, it's going to print out the corresponding I it's referring to. So I think usually I use this for loop structure most for reading in files, multiple files. So what I usually use it for is for example, this is a toy example in pseudocode, but let's just say I have a list of files. And this is like a list of file names. So maybe something like a.text, b.text, and so on. So what I would do with the for loop is I would do something like for I in the number of files I have. So list of files. I would maybe like read .csv or read.text. Yeah, like that or something. So this is what usually comes in D&D for nowadays, but I think it can come in handy for other things as well. So just to recap, this would be just saying for all of the files in this list, read them into R, and I usually assign them to something, which I'm not doing it. Okay, so that's the basic for loop example. This is more, I guess, a more formal explanation of what's going on. So the I is called the iterator. And at the first step, it starts at 1 because these pages start at 1 over here. You can also do something weird, like if you want to read only the even files, you could use the seek function that we just learned. And say for seek 2 to 20 by case 2, read only those even files. So it's pretty flexible on this for loop. And let's see here. This is another example of another potential vector that you can use. So if you run this vector, it just prints out everything in the list, in the vector. So basically, this I can refer to any number, any numeric vector. Okay, I think Jess has quite a few more examples. So I'll just scroll down using the actual R&D. Actually, she hides them, it's never mind. So we have that one example or one exercise, I think, for this for loop. Let me just make sure we have examples. Okay, so how about instead of doing this, how about instead of that, we look at maybe, yeah, we can look at the count variable in this data set and just improvising right now. Okay, so let's make a new R code chunk. That's done 100. That's done. Yeah, sure, 100. Okay, so here I think I'll just also introduce you to pulling some stuff out of data frames. So for this L width, which is our table, we can access columns by using the $sign. So if you do L width $sign, you can pull out different variables. In this case, you want count. So do L width $sign count, and then if you run it, you'll get a vector of all the counts in the data frame. So let's just say we're interested in finding counts less than 100. What you can do is you can start by printing out whether each variable or each entry is more than 100 or not. So I think your exercise can be take this L width count and just print out whether it is less than 100 or not. Okay. Go ahead and fill in the blanks here. Where to read?
I don't have it.
It is.
Okay. Oh, So, Yeah. No, we can go to algorithm.com, and then press command enter. Go below that. Yeah. Command enter. So it's the other. Yeah. Okay. Yeah, so I shop in both places because this console, yeah, because this is over here, the farm page, and it, whenever you run, it shows up in your name. Oh. It also shows up in the console, because that's, controversial, yeah. Yeah. Oh, yeah. Think of it. So we're just looking at all this count data. So let me just change the structure really quick. Okay, that should be updated now. Yeah, I can see this. There were a lot of people. That's virtual. Yeah. What's the hardest thing?
Basically,
This is a long one.
I'm gonna be real. I feel like but like, or I know that I should be the one. I ran it.
This is gonna be on.
Yeah. So you have like or somewhere in each right? So. Well, it was in the market.
The length of the site. Or it's.
Yeah.
Oh. Now we don't use all the time.
Yeah, we're the trial work.
So that's gonna tell us to do that. One. Outside, you want to put the little. Yeah. Yeah, but then how are you gonna sell it? Which-
Oh my God.
Does that make sense?
Okay.
And then now, if you want to say the ice district, now like that. So, yeah. That's it. That should do it. No, you could if you said if you wanted to scroll up.
Decrease.
Yeah, so, so not the.
Yeah, so. So first, I just want you made this like a little thing. On the list. And then you
After the lesson.
Then you want it. So then, we're trying.
That'll print this in line.
So then here, this is the. I just use it. Okay. There's like. So you.
It shows up on my notes, a lot of different lines of things.
So you understand what this is? I actually said, it's like for every.
Okay, so what?
Well, it's really great. Well, not long.
Yeah. And now you're going to change.
Okay, so you just read, so you're telling me every in this, like, yeah, and then it's so then it's that. But I'm saying, and it's the one you like.
So you need to finish, so I'm gonna have to go through this. And I do you want to have the value? So that's what they and process. Like double.
Yeah, it's great.
Yeah.
Not really.
But yeah. Okay, so something more explicit. I think that is the first example, because I think most people haven't really seen a formula before. We're gonna look at this example on 274. Okay, so we have this vector V is basically, I think 2, 5, all the way to 20, yeah, 2, 5, and so all the way to 20. And the for loop just says, for I and 1 to length B, do something. So let's parse this first line first. For I and length B. First of all, how long is B? Yeah, I don't know. Maybe it's 7. So, the length of B is 7. And the for loop starts by saying, for I in 1 to 7, pretty much. All right, so there's 7 entries, or there's like 1 to 7. So that means, basically, if you print I, the first time it goes through this loop, it's going to print 1. The second one is going to print 2. The 7th time, it's going to print 7. So basically, each time this loop runs, I is referring to a different number, the number that comes next after the previous one. So in this example, we're referring to VI. So what does this refer to? The first time this for loop runs, this refers to the first entry of V. The last time it runs, it refers to the 7th entry of V, or 20, right? We want to do something to this entry of B each time. So we're going to multiply it by 2. So basically now, the first time we run for this for loop, it's going to print 1. It's going to take the first entry of B and set it equal to 2 times the first entry of B. And it does that for all of these numbers in sequential order. Okay, did that help? Okay, great, and then. So if we look at this count function, we see that we also have this long vector of numbers. And that's kind of analogous to this B over here, right? For each of these numbers, we want to do something. So we can say for I and 1 to the length of this vector. We print something out. So now we know it's going to run the correct number of times. And the first one's going to run is going to refer to this first and the first entry. We can't refer to this first entry. And the last way it runs is going to refer to the last entry. So something which I did not do was actually show you how to access the first and last entries. But it was kind of implied in the earlier example as well. So you see here that we can access the first entry of this count data discount variable by using the square brackets one. That's like in here, it's the square brackets for the I entry. So that should give you a hint that maybe we should be looking at this. So we can do this and just look at the I entry using these square brackets. So now you want to see what this entry is less than 100. So all we have to do is add 100, less than 100. And we can see if this works. So you can't really see it because it's off my console, but it does print out all these trues and falses. And I'm not going to check each of them, but we can check a few. So this first entry, 164, is not less than 100, but the next one is, and that's pretty promising. So I trust this output, but you can verify for yourselves that this is correct. Yeah, so as a reminder, the dollar sign is what lets us access variables. So if you print out LWHIV, it's a data frame. So it has lots of other variables which we don't really need. But we can access just a count variable by using dollar sign and then count. We can access other variables by using dollar sign, other variable names like year. And in this way you can get yeah, basically different variables for the data frame.
Is that referring to the row?
Yeah, that's right.
So it looks like it's going, but then when do we reach the?
So right now we're just
Yeah, it has to be
yeah. Based on that one, probably gonna try to do some problem. Yeah.
So you have to be, so they'll come to check and count bracket. That will be your
But I was like, I don't like that. What are you really going to do?
Yeah.
Thanks to that. I think it's really hard. It's literally otherwise, I could just be.
Definitely.
Or all the way to 265. That isn't that high. Wow. But you could do it for IS, you have 4, and you want to check this.
Yeah.
So, yeah, so that's how it works. So it's just basically when you pass that option now. Then, so that's all.
Yeah.
Right, so it would be like, if I put a 4 here, and it was start with the 4 variable. That's like every 4. It was. It would go through. So if you want to do it every. Do that.
I guess back there.
Yeah. Yeah.
Yeah,
So get in trouble with I think you get
you need to know that. Yeah. But have you set up?
Okay, so it's like either.
Yeah. So the way it always is.
I would love to see like sweet thing.
Yeah.
Yeah.
That's really good.
They were hard to.
And then like,
It's useful sometimes when you're. Like when you want to see something on your time. And you're doing like some more complicated function as opposed to industry. You may want to do that.
Okay. Yeah, I was just asking, well, there's like, we just like recently started. Like, you know, what? I'm really getting into that.
yeah, the whole plan was to be for us to move into where the right now, we're gonna go spread out. Another yeah.
You're printing. Line.
Yeah, yeah, I lived that. Yeah, I stay around. Because Tuesdays, I like my. No, I don't. But they need people. They're different. Not possibly.
I'm going to, rest of this will be done hopefully for today.
They also.
Probably no student section, students playing with prompts and normal set of things. Let's see. So now, having talked about forwards, I'm here to tell you that we don't have to use them. Which is good, because I think they can be quite inefficient. So what we can do instead is something called factorization. So remember previously we doubled entries of a vector by using this for loop. Now instead of doing that, we can just use factorization. And the example for this is very simple. We have v like before, but if you just do 2 times v, it gives the same output as this for loop. So go ahead and run that. It's a lot more concise than a for loop. And it gives the same result, as you can see. And I think Richard at one point was mentioning this during your break. The question is, why do we use for loops? The answer is that sometimes they're more complicated functions than multiply by 2. And we want to be explicit about how we loop through those functions. And we also have to print out things that help us define. So in this case, it's much easier to just do 2 times v. But in a more complicated scenario, we do a for loop. And Janice here has a definition of vectorization, and it's that there are functions that work on whole vectors at once, rather than one at a time. Okay, so another example of this would be using multiplication. The multiplication vector or operator to multiply 2 vectors. So here we have v and w, which are these 2 vectors, 2 through 20 by 3, and we have 1 to 19 by 3. So if we had a for loop, we would have to say something like for I in length v, we do vi times wi. But here we can just say print v times w, and it gives us the same thing. So there we go. Dot products, I don't think most people know, or most people use dot products, but yeah, notice that if you wanted to multiply 2 vectors and add them up, then this is a way to do it. Okay, so I think we have 1, maybe 2 more sections of exercise. Really great. Yeah, okay. So we have 45 minutes. We can do this. You really have to do this first one. I think we'll just skip this one actually then. But here's some examples of important summary stats that you might find. So we have this v, we can sum, we have a sum function, we have a mean function, we have a median function. So just to recap, I call these functions because these are names of things that we can do to certain data. And this data goes inside parentheses. So anything which looks like this is called a function. And these functions that we're using right now are built into Base R. So another one that you might find interesting is this standard deviation function. So you can find the standard deviation of this vector as well. Okay. Okay, so I gave you a very brief overview over functions. To recap, they're basically like verbs, if you talk about, them in a language sort of sense. So these are verbs. And these are the things that you don't choose. These are like subjects, objects, nouns, whatever. So all these things that we've been looking up using the question mark function over here, like even C. These are all functions. So we're going to learn in the next section how to make your own functions or customize them. But we can often use these built-in functions for what we need to do in R. So the next two examples are going to be working with some vectors and vectorization, as well as some functions that are built in. So try going through these. The first few should not be too difficult. These last few might involve you looking up stuff on the internet or using the question mark function. So go ahead and try these, and we'll be walking around. Where's your notes? Every side. I mean, that's me. We don't want to be social. Yeah. Yeah, no. How did I get you? How did I start? Yeah, so it was 5 times. 5 Scottish. I think she was trying to tell me that if you work with any sort of framework for federation, like that to be, you have to use last name. This is the kind of makes sense of why you can have these people or video or get along with it or something.
Yeah. You still hear company.
Yeah. It's true, it's true. Yeah, first. The interesting stuff.
Yeah, it's whatever. Yeah, they just have to be.
Yeah. Yeah. Yeah, I should be fine. I did this last week too. So, it's like
Did you add them?
Yeah, so I'm gonna be such a good coach. Right now, I'm just like, so we're trying to add a coach. Yeah, that's right.
Yeah, so just
Yeah.
create
Yeah,
sector.
yeah, there you go. And now you can put your numbers on there, so take
Oh,
you
just
back.
random. Yeah, just whatever you want. And then another one that I'll.
And then you gotta do that. Together.
And go down, so, yeah.
I think that's what, yeah. Yeah, it was simple.
Can go inside the coach.
Oh, okay. Or do I have to sound like those lines is one sort of?
Go in the grade, I think you can,
As long as
uh,
I'm not good at snake.
not inside, inside the, like, yeah. like
Oh,
do
that
that.
should be fun. Oh, there you go.
Yeah. Yeah. Cool. Yeah. And then the other one, and two. Okay, great. And if you run this, just press the play button, then you can see the one of each. So that's great. Yeah, okay, so try doing the one percent, then see what happens.
So wait.
So make sure, yeah, make sure it's like you just type in everything out. Yeah.
Oh, add it.
Yeah, just type in that. Post was like, yeah, like. So see what that brings up? It's the one for speech. Yeah, okay, great. So that's the first. So as the third check. Yeah. Center. Yeah. And now it's linked to, so I want so then. I don't know. But recitals. Yeah, so that's after. So I did use.
And then.
Yeah.
Oh, sorry, so yeah, you're. Yeah, I. How you can add things that they're not different.
Yeah.
Yeah.
So.
Maybe different in my
Ooh, with it, our team.
I'm like off it right here.
So it's fine.
But it's crazy.
Yeah. See, yeah,
Probably.
so yeah, picture you have C and A. Yeah, it's the
Like, so. it's
No, I answered my own question. Never mind.
Yeah.
Yeah.
Oh my god.
Yes, when you get to the sort of which might make four. Yeah. And clear out. We just want to figure out so we're all figuring that. And add the two. It'll add these two, and then it'll do the weight, it'll also 57 pounds. And put it in here. And it'll still be the $4, even though we only had two down here. Which is what we do. Those two. But then why doesn't two and three? They have these. You add the two and three. Will you add a vector with a five? Yeah. And we'll figure it out.
Anyway, yeah, not really.
So ample is a function, actually, so we do not, how we have to look it up, using a customer or.
The errors.
Yeah, so if you search for the word into it was question mark, then
It's like.
yeah.
Because it's like.
Yeah.
Uh,
wasn't.
Well, yeah. So there was.
It's not that this is part
So this.
I.
So there's a higher what the container is words that are the two. Yeah, so I'm gonna try this stuff at some man. And then I'll push it and you can pull it.
Can you repeat numbers?
No problem.
You just repeat the.
What do you?
Like, so.
Well, I guess maybe say a picture.
And I am, but I don't feel like I do that. You know, I say you. I don't think I've ever.
So here this one.
Right.
Here you have. Yeah, right. There you go, yeah, and that wording is what she said. Okay, so we're going to go over, I think, just the last one out of these. So let's talk about what sorting samples do. So we have this V, which is this vector of 7 numbers. And it's already sorted actually from anything to from least to most. But let's say we'll just sort it the other way. So we can do that by using the sort function and using the decreasing equals true option in there. Okay. So that's what sort does. It sorts it in increasing or decreasing order. Now sample, is something which allows you to either randomly sample from a vector. So here I'm saying you want to sample 2 entries from this B vector. You can change it to be 3 or 4, whatever you want. If you just leave this blank, it's just going to sample randomly until it samples everything. So it's just like a permutation of the original vector. And again, you can figure out what these do by using the question mark here and looking at the documentation or looking on Google at our documentation page. All right, so these are all built-in functions, which are very helpful and which are usually what we just need to use. But we can also build our own functions. So building our functions is something that you probably will not end up doing in the near future, but you might eventually. So the function has this following structure, and this is kind of the behind the scenes look of how, functions like mean and sort and other functions are written. So we have this function named. So I guess in the case of mean, it would be something like mean. That's the function name. And then you have this function type, which tells R that this is going to be a function. Okay, so you have a function named mean. That's what we know so far. Now we need to give the function some arguments. And in this case, let's say we want to take a mean of a vector. So we can just say that there's a vector called vec1 that will take the mean of it. This just basically means that when we call this function, it'll be something like mean and then some vector here. Now inside this function, you'll give it details on what to do with vector 1. So in this case, what we're doing is we're going to sum up this vector and then divide by the length of the vector. And this is what we actually want to output. So to tell this function what to output, we'll use the return statement. And in this case, we could either just return this whole thing, or we can make a variable and return a variable. And this. Okay, so that's a very basic function. These can be quite complicated. You can get into output plots or tables eventually if you need to. Are there any questions on what functions are? Just to recap, you have the name of the function, then you have the assignment variable operator, then you have the function word, which tells you that it's going to be a function. Then you have what goes inside the function as an argument, and then you have it return something that you want it to return. And then body of it. Okay. So I guess Janice has an example function here called myfunc. So that's the name of the function. It takes in 2 arguments, A and B. And it first multiplies A and B. Then it adds A to 2 times B. And I guess this line is kind of redundant because you don't do anything with it, right? You don't return C, and C is not inside of his expression. So if you do myfunc 2 and 4 or something like that, then it'll output a number, which is 2 times 4 times 2. Okay, I think. Yeah, she also has this. So there are multiple ways to call a function. So you see here that we have 2 and 4. Blank on 2 and 4. She has more examples down here. You can flip the order of the arguments if you specify what A and B are explicitly. Like in this case, down here. Okay. Yeah. One more exercise section, and then we can go and talk about packages, which will lead into our discussion on tidiness in a couple of weeks. So in these exercises, you'll be part of your own functions that are fairly simple, but which are not in order necessarily. Okay, so try it 1 and 2, and then let me know if you have questions. I think so. Actually, my third and divine questions. So run this make sure it's run. Usually that I don't think so. That's a no release. So it's such a no. Yeah. Yeah, it's true. I don't know what's supposed to be.
Oh, yeah, so A is 5, and then it's 2 times 4. So 8, so 8 plus 5.
Oh.
It's not, yeah, so it's.
Oh, it's yeah, multiplication goes for, okay, yeah.
Yeah, so
Okay.
there's a slide, and then you do anything, so all this matters, and just put your.
Okay, it's just
line, which are.
Oh, okay, so then, interesting, oh, I see.
But if you would add, if you had.
We'll take two. First, like this. But I want.
Yeah. I could just type it there. Like that. Okay, I just the only way for not, I heard the same one that I found. No, it doesn't matter. That one got me all this stuff with like relative numbers or. And I never. Oh.
Make sure that you can just function, so you have to put it on off there. After the assignment over.
You have to start on.
Okay. Yeah, let's go for the answer to the first one. So remember that we have our function name, in this case I'm calling it summing. We have our assignment operator. And then we should tell it that it's a function. So we have this function keyword over here. So here it says the inputs are two numbers. So we need two arguments in this function. The first number should add and the second number should add. And inside of these curly brackets, there's the body of the function. So what you're going to return is none1 plus none2, right? And you're going to output it, so you're going to put it inside a return bracket or returns function. So this is your summing function. Now you can try it out. See summing 10,000 plus 3. That's 10,003. Okay, so this second one is from a previous problem. And you might remember this equation that you got from the previous problem. You can just copy paste it into this function, which takes in A, B, delta, mu, and T. And make sure that it returns it. So once you run this, you can just say viral load, whatever parameters that you want to do here. I'm making up numbers right now. Got a very small number. And a nice thing about functions is that if we didn't use a function, we'd have to define, well, we'd have to like write this out every time. But we can use this function to do many different, I guess, parameter values very quickly and compactly, which is nice. And we can even, do things like vectorize time, which is what we did before. So we did let's see if this works. 1 to 10, t equals to 10. Let's try some 10. I think I have an extra number here. Yeah, that's fine. So yeah, a lot of programming is about making things shorthand. So variables are shorthand for certain expressions or more complicated formulas. Functions are shorthand for complicated procedures that you want to do, or series of functions that you want to do. So this is how we make code more readable and more efficient. Okay, are there any questions about any of the programming basics we've learned about today? it's a lot to take in for one class. So I'll make sure that this version is pushed hopefully by next week. See if I can look it over before the week after. Okay. So next week we're gonna skip class, and we have a class the week after. So we're gonna break. And if you have any questions in the meantime, feel free to reach out to Josh. I'm not sure you have I'm not sure you have my email, but I guess I could put it up on the board later, you know. But as a maybe sort of teaser for the next thing we need, we're going to talk about libraries and in particular one library. And this library is called Tidyverse. I think a lot of people use it nowadays. If you interact with the statistician who uses R, they probably use Tidyverse. So this is something that's very useful to learn if you want to visualize or wrangle data. So libraries, we're going to install it using something similar to this. So to import the commands that Tidyverse lets us do, we need to use the library commands. And then we can use things like this function over here, which comes from the fire. And a lot of these you don't have to, we're not going to install because they've been pre-installed already. But kind of using libraries is a two-step process. First, you need to install a package. And then you need to use library to load it into your workspace. So installing packages looks like this. You use the install packages command. And then you can remove stuff by using your packages, and you can load stuff by using library. I'll draw something on the board later about all this, I think. But I think what we want to go through also before we end class is more about data frames. So you saw an example of a data frame already, which is this, I guess, L width. If we want to generate data frame from scratch in R, it's kind of difficult, but we have to put each column, I guess, into a vector, and then each vector goes into this data.frame, I guess, object. So in this case, we have the names of some dogs and cats, we have the species, and we have the ages. And we can create a data frame by putting all of these together. So here we have a column called name, a species called species, a column called species, and a column called age. So we look at DF, it's exactly a column, a series of columns with those values. Usually we don't have to do this, thankfully. We just read this in from files which are pre-existing. So things like LWID, which would come in a CSV file, we can read that in pretty easily. We also have some built-in files just for learning purposes in R. So we have this MT cars, which you can read in. And if you want to look at it, it's basically just different car brands under miles per gallon and a lot of other things like weight. I don't know what values are, number of gears, and so on. And you can do stuff with other built-in things. So yeah, we'll be using a lot of built-in data frames for fun stuff later with a Tidyverse and visualization. Just to go over packages and what R is, I guess more concretely, I want to draw the board a little bit. So R is this free open source kind of software. And you might know that's different from stats, just the other big stats language, because for stats, it's not open source. Only people who work in a company can create new commands and stuff. But for R, anyone out there who's a programmer can create a new package and create some commands or functions. So we have Base R, I guess, which is what R comes installed with. And out in the internet or GitHub or GitLab, you have all these maybe thousands of packages out there that have different potential commands you can use. So some of these are very specific, like there's a package, I think, for RNA-seq data. I don't know the name of it. I don't work with it, but there's a package out there. But it doesn't come with Base R. You have to install it if you want to use it. So basically, if you want to have functionality outside of Base R, you can look stuff up on the internet, like a R package for RNA-seq, for instance. And then you can pull it into your workspace with the install packages command. And once it's installed, you can load it into your current workspace or R&D using the library command. So I guess in 2 weeks we'll be doing this with Tidyverse. So this is another one of the packages out there. And Tidyverse is nice, much nicer than Base R in some aspects because it allows for very readable code. Base R does things well, but it's not very readable in a lot of instances. So Tidyverse is for readability and for some very pretty visualizations. Okay. So I guess next we will talk about how to use this Tidyverse to clean up some data and maybe filter it and look at certain columns to see data of interest, basically. And then after that, Richard will be giving a lecture on how to visualize data, which will be probably the most fun lecture. Okay, so that's it for today. If people have questions, feel free to stay after and ask me. Otherwise, have a great week. Great couple of weeks. I'll see you in a couple weeks. Thank you.